Ever felt like equations were a puzzle waiting to be solved? Hello math learners, Hassan here. In this video, we'll be diving into the foundational concept of one-step equation. So let's begin. Okay, so let's first look into the definition of an equation. An equation says that two things are equal and it will have an equal sign like this. So here we have x minus 2 equals 4. This says that the left side is equal to the right side. So an equation is like a statement. This equals that. Now, when you solve the equation, the answer to that equation is called the solution. So a solution is a value we can put in place of a variable that makes the equation true. Over here, what can you put in place of the x to make the equation true? When you put 6 in place of x, we get 6 minus 2, which is equal to 4. Now, this 4 is equal to 4. That means this is a true statement. So x equals 6 is our solution to this equation. How about other values for x? For x equals 5, we get 5 minus 2 equals 4, which is not true. X equals 5 is not a solution. If we put x equals 9, we get 9 minus 2 equals 4, which is also not true. So x equals 9 is not a solution. Remember, 5 minus 2 is 3 and 9 minus 2 is 7. So 3 is equal to 4 or 7 is equal to 4. These are false statements. So that's why these are not turned as the solution. So the only solution we have for x is x equals 6. Now, how do you actually solve these using algebra? To solve these algebraic equations, we need to use inverse operation. Now, let me explain this clearly. Inverse operations are two operations that undo each other, such as addition and subtraction. We perform the same inverse operation on each side of an equation to produce an equivalent equation. Now, equivalent equations are equations that have the same solutions. Let's see this example over here. We have x minus 3 is equal to negative 5. So first, we write the equation. Now we see the operation between x and 3 is subtraction. So we use the inverse operation. The inverse operation of subtraction is addition. So we use addition property of equality on both sides. So we add 3 to each side. Now these 3 and these 3 cancel each other out. So we have x equals negative 5 plus 3 gives us negative 2. So this is the solution to our equation. We can see that we just used one step to solve this equation. So our answer is x equals negative 2. Now let's look at this example over here. In this case, the variable is on the right side. It does not matter whether you have the variable on the left side or the right side. Usually the standard approach is we keep the variable on the left side, but we can also solve the equation by keeping the variable on the right side. So over here, the operation between the variable and the number or the constant is addition. So the opposite operation or the inverse operation we apply over here is subtraction. So we subtract 2.8 from both sides. So we use subtraction property of equality. Now the subtraction cancels these two numbers. So now we have negative 1.9 equals y. We can also write this as y equals negative 1.9. Okay, the next problem we have is negative n over 5 equals negative 3. Over here, we can see a division sign. Now the opposite of division sign is multiplication. So we need to multiply by 5. But if you multiply by 5, it does not remove this negative sign in front of the variable. Whenever we solve the variable, we always keep the variable to be positive. So we need to multiply both sides by -5. So we multiply both sides by -5. These two negative signs cancel each other out. 5 cancel each other out. So we have n equals -5 times -3. It's positive 15. So our solution is positive 15. N equals positive 15, or n equals 15. So remember, if you have a negative sign, we always multiply by a negative number to cancel that negative sign. The last example that we have is 1.3z equals 5.2. Now this operation between 1.3 and z is the multiplication. The inverse operation, or the opposite operation that we need to apply over here, is division. So we divide both sides by 1.3. So you can see 1.3 cancel each other out. So we have z equals 5.2 over 1.3, that equals 4. So our solution is z equals 4. So a quick summary is that one-step equation is an algebraic equation that takes you one step to solve. And that's what we did in the last 4 practice examples. The trick here is that we try to solve the equation by adding, subtracting, multiplying, or dividing. And when we do that, we'll get either x equal the value or the value equals x. Remember, x equals 2 is same as 2 equals x. Both are representing the same meaning. Here we have a few one-step equation problems. Let's see how we can solve these problems. Number 1, it's 0 equals -8 plus x. Now, whenever we are trying to solve x, we need to get rid of everything else to the other side of the equation sign. So in this case, we have this -8 and this x. Now, to get rid of this -8, I need to use the inverse operation. Now, we always look for the sign in front of the digit. In this case, it's a negative sign in front of 8. So I would put a +8 to cancel this negative. So I do this on both sides of the equation. So once we do that, we have 0 plus 8, that is 8 equals x. Now, the standard form is we keep the x on the left side of the equation, so you can reverse this and you still get the same answer, x equals 8. That is our answer here. Number 2, we have 3 equals -3 plus a. So again, to get rid of this -3 from the right side, I just need to do the inverse operation. So I do +3 on both sides. Once we do that, we get 3 plus 3, that is 6, equals a. Now again, we can write this as a equals 6. So they basically mean the same thing. 6 equals a and a equals 6 are both correct. Number 3, we have the variable on the left side of the equation. That means we need to get rid of this -10. Now again, whenever we are trying to remove any number, we always look for the sign in front of the digit. So in this case, this -10, this 10 has a negative sign in front of the number. So we put a +10 on both sides. So this cancels out and we have x equals -14. -24 plus 10, that is -14. Number 4, we have -2 equals p over 5. Now this fraction bar means division. That means we need to do the inverse operation of division, which is multiplication. So in this case, we multiply by whatever is required to get rid of this fraction. So here p is divided by 5, so the inverse operation is multiplication by 5. And we need to do it on both sides. So if I do multiply on both sides, this 5 cancels out and we get 5 times -2, that is -10 equals p. So -10 is equal to p, or we can write p is equal to -10. Let's look at these problems over here. Number 5, we have 12 plus p equals 1. We need to get rid of these 12. So the operation is addition, and we see that we have a plus sign here in front of 12. So we need to do minus 12 on both sides. So once you do that, 12 cancels out here, and we get p equals 1 minus 12 is negative 11. Number 6 is interesting. We have n plus negative 13 equals negative 21. Whenever we have two signs next to each other, we always try to combine them into a single sign. Here we have a plus and a negative sign, so you combine this into a single sign. So in this case, we can write this as n minus 13 equals negative 21. So plus and negative sign would multiply together to give you a minus sign here. Now we can see that we have a minus operation. So the sign in front of 13 is minus. So we just do plus 13 on both sides. So 13 cancels out, and we get n equals negative 8. Number 7, we apply the same strategy. We have p minus, within parentheses, negative 9 equals negative 2. So you can combine these two signs together. So you can write it as minus and negative sign would be a plus. So p plus 9 equals negative 2. Now we see the sign in front of 9 is plus. So we need to do minus 9 to cancel this 9. And we subtract 9 from both sides. We get p equals negative 2 minus 9 is negative 11. Let's look at number 8. Number 8, 13 times r equals negative 39. We can see that we have a constant in front of the variable which represents the multiplication. So 13 times r, the opposite of multiplication is division. We divide by 13 on both sides. And we get r equals negative 39 divided by 13 is negative 3. Perfect. Number 9, we have m plus 8 equals 15. Again, same strategies can be applied over here. We see the sign in front of 8 is plus. So we do subtraction. We do minus 8 on both sides. And if you do that, we get m equals 15 minus 8 is 7. The last one that we have here is b minus negative 2 equals 0. So again, we see two signs next to each other, so you can combine them into a single sign. Minus and negative here can be written as a plus. So b plus 2 equals 0. Now we do the inverse operation, which is minus 2 on both sides. If you subtract 2 on both sides, we get b equals 0 minus 2 is negative 2. Awesome. We navigated through the realm of one-step equations, understanding their structure, solving equations involving addition, subtraction, multiplication, and division. That's it for this video, and I will see you in the next one. Now let's get to study.